Good morning, student. Let's start today's class. In today's class, we are going to discuss about traffic management. Okay, there are a number of issues related to congestion control that might be included under the general category of traffic management. Okay, it is in its simple form. Okay, congestion control is concerned with efficient use of network, okay, at a high load. Okay, the various mechanisms discussed in the previous section can be applied as the situation arises, without regard to the partial source or destination affected. When a node is situated, okay, and most describe packets, it can apply some simple rule, okay, such as discard the some recent arrival. Okay, however, other consideration can be used to refine the application of congestion control technique and discard policy. We briefly discuss several of these areas. Okay, here. Okay, now traffic in generally traffic means the load or the heavy load in the input side or output side of the sender. Okay, now congestion means similar. Okay, so congestion problem is under the traffic. Okay, and by this traffic management we can control the congestion, or vice versa, means we can control congestion to control the or manage the traffic. Okay, so here the traffic will be managed, okay, by several uh, by seeing the several areas, okay, of network. Okay, the first one is fairness. Okay, as congestion develop, flow packets between source and destination will experience increased delay. Okay, and with high congestion packet loss. Okay, in the absence of other requirement, we would like to assure that the various flow suffer from congestion equally simply to discard on a last in first discard basis may not be fair. Okay, so in fairness, you know, when the congestion happened, if we discard if we discard the last in first, okay, then that is not fair. Okay, as an example of a technique that might promote fairness, a node can maintain a separate queue for each logical connection, okay, or for each source destination pair. Okay, if all the queue buffer are the queue length, okay, then the queue with the highest traffic load will suffer discard more often. Okay, allowing lower traffic connection a fair share of the capacity. Okay, so in fairness, that when when we discard the information is not fair, but in the place of that discardation, okay, we can use another buffer, okay, or another memory to store that information or discarded information. Okay, and after that, after some time, we can use them. Okay, now next one is quality of the service. Okay, we might wish to treat different traffic flow differently. Okay, for example, as a as point output, some applications such as voice or video are delayed, sensitive but low intensity. Okay, others such as file transfer and electronics mail, okay, are delayed, in insensitive but loss sensitive. Okay, still others such as in interactive graphics or interactive computing application are delayed, sensitive and loss sensitive. Okay, also different traffic flow through different properties. Okay, for example, network management traffic, particularly during the time of congestion or failure, in more important than the application of a traffic. Okay, now the next one is reservation. Okay, reservation means on the way of avoiding congestion and also to provide assured service to application. Okay, is to use a several scheme. Such a scheme is an integral part of the ATM network. Okay, when a logical connection is established, the network and the use of enter into a traffic contact. Okay, which specifies a data rate and other characteristic of the traffic flow. The network agree to give a definite QoS so long as the traffic flow within the connection contact parameter. Okay, excess traffic is either discarded or handled by the best effort basis on the subject to discard. Okay, now this is the these are the three areas by to avoid the congestion. Okay, next one is congestion control in packet switching. Okay, packet switching network. Okay, a number of control mechanism of congestion control in packet switching network have been suggested and tried. The following are the example. Send a control packet from a congested node to some or all sources node. Okay, this choke packet will have the effect of stopping or slowing the rate of transmission from source and hence limit the total number of packets in the network. Okay, this approach required additional traffic on the network during a period of congestion. Okay, this is the one method. The next one method is rely on the routing information. Routing algorithms apparent uh, such as ARPANET provides link delay information to the other node which influence routing decision. This information could also be used to influence the rate at which the new packets are produced because these delay are being influenced by the routing decision. Okay, they may vary too rapid to be used effectively for the congestion control. Make use of the third one is make use of an end-to-end probe. Okay, packets such as packets could be transparent transparent to measure the such a packet could be time stamped to measure the delay between two particular endpoint. Okay, this has the disadvantage of adding overhead to the network. Okay, now the fourth one is allow packet switching node to add congestion information to the packets as they go by. Okay, there are two possible approaches here. A node could add such information to packets going in the direction of opposite of the congestion. This information quickly reach the source node, which are reduced the flow of packet into the network. Alternatively, a node could add such information to packets going in the same direction as the congestion. The destination either ask the source to adjust the load or return the signal back to the source in the packet. Okay, going to the reverse direction. Okay, this these are the four points for congestion control in packet switching network. Okay, that's all for this class. Thank you.